morning to all of you. I am Dr. Bhagwati Sharan from Department of CSCAI of Kite University. So today I am going to cover the topic stack, that is a part of data structure. So coming to the topics, like what I will cover, I will cover the introduction of the data structures, then some operations, then logics for insertion, deletion, and traversing the element, then implementing the stack, and some examples. So basically data structure, if we are coming, what is like data structure? So this is a particular way of storing and organizing data. Why not only storing? Because in data structure, we are storing and we are organizing this data in a or way that we can use it efficiently. Means our time will reduce to access the elements. Then there are basically two types of data structure. One is linear, second one is non-linear. Then if you are going for the types of linear, then array, stack, queue, linked list, and tree and graphs are the non-linear. So out of this, today I will cover the stack, that is a part of linear data structure. So if you are going for a stack, so a stack is normally we are defining as a last input, first output. Last input, first output means suppose if you are pushing something here, so it will come and means one side access only. There is one side access means from second side we cannot access, so we can access the elements from the top only. So we are saying first in last out or last in first out means which one is going first, so that will come out last, and which one is going or which one is going last, which can come first, because last element will be on the top. So basically we can do the insertion and deletion, so that is only possible on the top of the stack, that is the upper level of the stack. Now if we are coming for the operations, what are the operations we can do with the stack? So one is push, means we can insert a element on the top. Second is pop, means we can delete the element from the top. Size means gives the number of element in presence in the stack. Then top will return the top element without removing it. Then there is another one like is empty. Is empty means each stack is empty means if nothing is there, so that will be the condition of underflow. Then is full means if stack is already full, so that is a condition of overflow. So these are the possible operations you can do with the stack, and all these operations will be like applicable to the top of the element only. We can do any operation from the top of the stack. So suppose if we want to insert any element in the stack, so how we can insert? So firstly, for inserting any element, we need to check is there any space is available or not in the stack. If a space is not available, it means we cannot push any element. If a stack like a space is available, then only we can push the element. So first condition is if top is equal to max. If means top of the stack that is equal to the maximum level. So it means a stack is full. We cannot push any element. So we can print directly the overflow and it will return. But if it is not fulfilling this criteria, means if top is not equal to the max, then it means we can push any element. We can give it the element because there is some space in the stack. So firstly, our top will increase by 1, like whatever the top value is there, so that will be increased by 1. And then we will set a new top, like set top is equal to top plus 1, means our top will be changed by 1 because we are inserting one element. And the top 1 for the top, we will give the item set. If we will go from set stack top, means top element of the stack is equal to item. We will give the item to the top of the stack, and we have already created the new top that is increased by 1. So if we are saying like we can we have combined 2 and 3 also, we can combine, and directly we can give a stack sorry stack plus plus top is equal to I. So it will handle both the increment operation and the insertion operation. And then it is like if it is happening, then it will print the successful insertion and then completion of the top. Suppose if we want to delete the element from the stack, then what we can do for that, we need to check, like when we are going for deleting something, removing something, so there should be some element also. So for checking that one, is there any element available or not, so we are going to check the underflow condition. Underflow condition means if there is no element is available, so we cannot remove, so it means that is a condition of underflow. So if top is equal to 0, top is equal to 0, it means the stack is empty. So stack is empty means no element is there. So we cannot remove any element because there is no element. So for that, it will represent underflow. If a top is equal to 0, so is empty stack. So it will print the underflow condition and it will return. But if it is not giving top is equal to 0, it means if top is not equal to 0 means some elements are available. Some elements are available, then we can delete the element. So for deleting the element, we are using pop operations. So for doing the pop operation, basically, for doing the pop operations, we are doing one is decrement in the top, because where we are inserting, so we are incrementing the top. But when we are decreasing, so we are decrementing the top, and then top is equal to top is equal to top minus one. So it means our top is decreasing, so that element is getting decreased by the pop operation. Combinedly, we can both the 2 and 3 we can combine. We can write like item is equal to stack top minus minus means firstly top minus minus means firstly it will delete the element, then it will decrease the top. So this one, then if element is deleting, then it is printing the successful element is deleting, and then it is completion of the program. Then suppose if we want to find any element or traverse the element, so what we can do? So we are searching for like top is equal to 0 or not. Top is equal to 0 means traversing the element means if we are going for one by one to the element. So definitely there should be element. If underflow condition is there, so we cannot go for element. So because of that, we are for traversing, firstly we are checking the underflow condition. So for underflow condition, basically we are checking top is equal to 0 or not. So if top is equal to 0, it means there is no element, so traversal is not possible. We cannot traverse. But if element is available, this condition is getting like false. So we can initialize a variable. Again, variable. Why we want variable? Because variable we can keep on increasing the variable and we can access the elements. So like said, one we have created one variable I. Then we have check the condition for like this three condition will come again and again until it is getting to the like the minimum one. So how it will go? It will go like firstly print stack I. Stack I means it will print the top element of the stack. Once it is getting print, so then it is decreasing the like I operation by one. So like this it will come, and it will come by decreasing again and again, printing and decreasing, printing and decreasing. It will come top is equal to 0. So that time stack will be like means all elements we have already completed. So we don't need again the traverse. Means traverse will be complete. Then coming to the implementation portion, like basically we can implement uh, a stack using two data structure. One is array and one is linked list. So when we are going for array, basically, when we are knowing the size of the stack. So if we are knowing the size, means how much size we need. So we are going for a array to use. Means we are using the array to get the stack. So because array is a fixed one, no? Array is a fixed one. So because of that only we are going for means if size is fixed means we are known to us, so we are going for array. If size is not fixed, then in that condition we are going for the linked list condition. So if we are going for one example like how a stack will work if we are going working with the array one. So suppose we have created one array. So there are six elements here, and one is top because we need two for implementing. One we need array and one we need top element. If you see earlier, So we have mentioned earlier here also, we need one, this is a stack and this is top. So we need one array for this one, and top will be a separate. So if we are giving push one, so push one means firstly it will check, how it will check, like if we are going for pushing, it means it will check any like it is filled or not completely. So it means overflow condition it will check. So here no elements is available means space are available, they can, we can push. So for that, if pushing push operation is possible, so means top will be incrementing by 1. If you remember, top, firstly we are incrementing the top. So top we will be incrementing by 1. So top from -1 to it became 0. And then 1 came at the 0 index. Then if we are going for push 2, so again it will check the overflow condition and space are available. So no overflow is there. So 2 will come here and top will increment by 1. Similarly for push 3, if we are going for push 3, then top in like top again increment by 1 and then 3 came to the index. If we are going for push 5, so again 5 came here and 5 at the index 3 and top is at the, like top value will be 3. Again push 10, so similar way we have done the push 10 and top has increased. So now if we are going for pop, so if you remember, for pop basically what we are doing, basically firstly we are setting the top value at the element. So it is already there, 3 and 3 index. Top we are setting at the that value, and then we are doing top is equal to top -1. So this value will be getting removed pop. So pop operation is performed. Pop operation will remove the basically last element, I mean top upper element of the stack. So this will remove this top element 5 will remove. So 10 is the top one, so 10 will remove and we will get the top application and indirect application. So direct application means we can check the parenthesis, infix to postfix recursion. So recursion means function calling itself again and again. Then if you are going for like undo command, that is like any undo command we are doing, so that is also kind of a stack. Call history, web browser history, message notification, post uploading Facebook or Instagram. These are the all the direct application of the stack. If you are going for indirect applications, so that's why search, effective like the order in order post order, then with by search, that is a level order. So these are two like direct and indirect application of the stack.